Hey everyone, welcome. We're about to tackle a topic that sounds super complicated, multithreading in Java. But don't worry, I'm going to show you how simple it can be, all thanks to a really cool analogy. So, here's a weird question for you. How is a Java program like a busy restaurant? Yeah, I know, it sounds a little out there, but trust me on this one. If you can get your head around this, everything else is going to click into place.
Okay, picture this. A restaurant with just one waiter. He's running around like crazy, right? He can only take an order, then bring out food, then clear a table, one thing at a time. The entire restaurant is bottlenecked by this one person. But now, imagine that same restaurant with 3 waiters. Suddenly, they're serving multiple tables all at once. The whole place is humming along, way more efficient. That right there is the big idea.
So in our restaurant story, each one of those waiters, that's what we call a thread in Java. It's really just a single path of instructions for the computer to follow. In fact, when you run any Java program, you've already got one thread working for you, the main thread. But the real magic happens, and the whole reason we're here is when you start hiring more of those waiters.
All right, so why bother with more waiters? I mean, what are the actual benefits of multi-threading? Let's get into why this is so important for pretty much every app you use.
You know that super annoying thing that happens sometimes? You're in an app, you click a button, and boom, the whole thing freezes. The screen goes gray, you can't click anything, you're just stuck. That is the perfect example of a single thread problem. Your one and only waiter is off doing some really slow job, and it just can't pay attention to you until it's finished.
And the solution? You guessed it, multi-threading. You can hand off that slow work, like saving a massive file or downloading something from the internet, to a brand new background thread. This frees up your main thread to do its most important job, keeping the app from freezing. The user can just keep on clicking away, having no idea that all this heavy lifting is happening behind the scenes.
But wait, there's more. Think about your computer today. It's got a processor with multiple cores, right? It's like having a brain with multiple parts that can all think at once. If your program only uses one thread, it's like trying to do a huge jigsaw puzzle but only using your left pinky. The rest of your powerful brain is just sitting there doing nothing. It's just a massive waste.
And this chart shows you exactly what I'm talking about. Look, on a computer with 4 cores, a single threaded app might only be using 25% of the machine's power, but a multi-threaded app, it can spread the work out over all the cores, hitting 100% and getting the job done way faster. Okay, enough about the why. I think we get it, it's important. Now for the fun part, the how. Let's dive into Java's super simple recipe for making and kicking off your own threads. And you know what's really great? The stuff we're about to cover is timeless. It doesn't matter if you're using Java 8 or Java 21 or something that hasn't even come out yet. These basic concepts are the same. What you're learning right now is a skill that will stick with you.
It honestly just comes down to 3 easy steps. Step 1, you make a new thread object. Step 2, you tell it what to do, and these days we usually use a nice clean lambda for that. And step 3, you call the .start method, and that's what kicks the whole thing off.
Now, this is absolutely crucial. That command, .start, that is the magic word. When you call .start, you're not just running your code like normal. No, you're telling Java, hey, go create a whole new parallel universe of execution and run my code over there.
Okay, theory is one thing, but seeing it in action is another. Let's look at a really simple piece of code and actually watch 2 threads running at the exact same time.
So here's the plan for our little experiment. We're going to have 2 threads. Thread 1 is just going to print hello 5 times. Thread 2 is going to print world 5 times. And just to make things interesting, we'll have them both take a quick half-second pause between each print. So, what do you think the output's going to look like?
And check it out. The output is all jumbled up. It's not 5 hellos and then 5 worlds. They're all mixed together. That's because both threads are running completely on their own at the same time. One prints, then maybe the other one gets a turn, and they just trade back and forth.
And this brings us to probably the single most important rule of basic multi-threading you need to remember. The exact order things happen in is never guaranteed. You can't control it. You don't get to say which thread runs when. That's all up to your operating system and the JVM. So you give up a little bit of control, but what you get in return is a system that can run things as efficiently as possible.
All right, let's pull all this together. If you walk away with just a couple of things from all this, let it be these key points. First things first, and this is a mistake everyone makes when they're starting out, you have to call .start. If you call .run instead, you're not actually making a new thread. Your code just runs in the same old thread you were already in, and you get zero benefits. So remember, .start is for starting a new thread, .run is a trap.
So let's recap one last time. Why do we do this? To make our apps feel snappy and to use all that horsepower in our CPUs. What is a thread? It's just its own little path for our code to run on. And how do we do it? Just remember the recipe. New thread, give it a job, and call .start. Now, what you've learned here today, this is the bedrock. This is the foundation. As you get more advanced, you probably won't be making individual threads by hand like this. You'll move on to amazing tools like executors, which are like hiring a manager for your whole team of waiters, or even the new virtual threads, which lets you handle thousands and thousands of tasks super efficiently. But here's the thing, they all build on the exact same core ideas we just talked about.
So I'll leave you with this final thought. You've now officially mastered handling 2 threads at once. But what happens when you need to handle 200, or maybe even 2,000? Answering that question, well, that's your ticket into the entire amazing world of advanced concurrent programming. And it all starts with the foundation you just built today.